A routine service of a modern petrol car in the UK usually takes place in a workshop environment designed for predictable, repeatable tasks. The vehicle is brought into a service bay and positioned so that access to the engine compartment, the underside, and the wheel areas is straightforward. The engine is typically allowed to settle into a stable, non-running state before any checks begin, with residual heat dissipating gradually. During this time, general observations are made about the external condition of the vehicle, including the body panels, lights, mirrors, and glass, noting anything that may affect visibility or compliance with basic road requirements. Once the vehicle is stationary in the bay, the bonnet is opened and secured, allowing the engine bay to be viewed as a whole. Modern petrol engines are usually compact assemblies with multiple plastic covers and shrouds, designed to reduce noise and protect components. These covers are either partially removed or left in place depending on access requirements. Attention is given to the overall layout, the engine block, ancillary components, belts, hoses, wiring looms, and fluid reservoirs are all visible to varying degrees. The condition of these elements is assessed visually, looking for signs such as residue, discoloration, or looseness that might indicate wear or deterioration. Fluid levels are a central part of a routine service. The engine oil level is checked using the dipstick, where fitted, or via electronic measurement systems on some newer models. The oil itself is observed for color and consistency, as these characteristics provide information about its condition and age. Brake fluid, coolant, and power steering fluid reservoirs are inspected in a similar manner, each having clearly marked minimum and maximum indicators. Windscreen washer fluid is also checked, as it is considered part of basic vehicle operation and safety, even though it is not directly related to engine performance. The air intake system is another area commonly reviewed during servicing. The air filter housing is located and opened, allowing the filter element to be examined. In modern petrol cars, this filter is typically a pleated paper or synthetic material designed to trap fine particles. Its surface appearance indicates how much airborne debris it has collected since the last service. The housing itself is also inspected to ensure it remains properly sealed, preventing unfiltered air from entering the engine. Battery condition is routinely assessed, even though many modern vehicles rely heavily on electronic systems that manage charging and power distribution. The battery terminals are checked for cleanliness and secure connections, and the casing is examined for swelling or damage. Some workshops use electronic testers to measure battery health, while others rely on visual inspection and system data. Associated wiring and grounding points are also reviewed to ensure continuity and stability. Attention then moves to belts and hoses within the engine bay. Auxiliary drive belts, which power components such as the alternator and air conditioning compressor, are inspected for signs of cracking, glazing, or uneven wear. Rubber hoses carrying coolant or other fluids are checked for softness, brittleness, or surface deterioration. These components are designed to withstand heat and vibration, but gradual aging is expected and monitored over successive services. After completing checks in the engine bay, focus shifts to the vehicle's interior systems, often while the car remains stationary. Dashboard warning lights are observed during ignition cycles to confirm that indicator lamps illuminate and extinguish as expected. Controls for lights, indicators, horn, and windscreen wipers are operated briefly to confirm basic functionality. Climate control systems may be switched on to ensure airflow and temperature response appear consistent, without assessing performance in detail. The service process then usually involves access to the underside of the vehicle. This is achieved by raising the car on a lift or positioning it over an inspection pit. Once elevated, the underbody becomes visible, including structural elements, exhaust components, and suspension parts. The exhaust system is examined along its length, from the engine manifold area towards the rear, looking for corrosion, loose mountings, or signs of leakage. Heat shields and brackets are checked to ensure they remain securely attached. Suspension components such as springs, dampers, and mounting points are observed for obvious damage or fluid leakage. Steering linkages and joints are also inspected visually, noting any excessive play or wear that might affect vehicle handling. Modern petrol cars often have protective undertrays, which may be partially removed to allow access to service points. These panels are checked for secure fastening before being refitted. With the vehicle raised, the engine oil drain point and oil filter location are accessible. The existing oil is allowed to drain from the sump in a controlled manner, collecting in a container designed for waste fluids. The flow rate and appearance of the oil are observed during this process. The oil filter, whether a cartridge type or a sealed canister, is removed and replaced with a new component designed for the specific engine model. The sealing surfaces are cleaned to ensure proper fitment. While the oil is draining, other underside checks continue. The condition of brake pipes and flexible hoses is reviewed, looking for corrosion or abrasion. The fuel lines, typically routed along the chassis, are also observed, ensuring they remain properly clipped and protected. In some cases, the condition of the catalytic converter and associated sensors is noted, as these are integral to emissions control in petrol vehicles. Once the oil drainage process has completed, the drain plug is refitted and secured to the correct specification. Fresh engine oil of the appropriate grade is then introduced through the filler point in the engine bay. The quantity added is measured carefully to align with manufacturer specifications. After refilling, the engine may be started briefly to circulate the oil, after which the level is rechecked and adjusted if necessary. As the service progresses, the vehicle is lowered back to ground level. The wheels and tires are then given attention. Tire tread depth is measured at several points across each tire, ensuring even wear patterns are present. The sidewalls are examined for cuts, bulges, or cracking. Tire pressures are checked and adjusted to recommended values, which are often displayed on a label inside the vehicle or in the service documentation. Brake components visible through the wheels are also assessed at this stage. Disc surfaces and pad thickness are observed where possible, noting wear levels and surface condition. Although a full brake strip down is not part of a routine service, these visual checks provide an indication of braking system status. Wheel nuts or bolts are inspected to ensure they are correctly seated and free from damage. Inside the vehicle, service indicator systems are addressed. Many modern petrol cars use electronic reminders to signal when servicing is due. These systems are reset using diagnostic tools or manual procedures specific to the vehicle. The onboard diagnostic port may be accessed to scan for stored fault codes, providing information about engine management and emission systems. Any codes present are reviewed for relevance, distinguishing between historical records and current issues. Throughout the process, the vehicle service record is updated to reflect the work carried out. This may be a physical service book or a digital record held within manufacturer databases. Details such as mileage, date, and type of service are recorded consistently. As the service draws on, attention remains on ensuring that all components previously accessed are returned to their normal positions, with cover secured and tools removed from the working area, while ongoing checks continue around the engine bay as the system settles back into its usual state. After the initial mechanical tasks have been completed, the service process continues with a further review of systems that contribute to the day-to-day operation of the vehicle but are not always immediately visible. Attention is often given to the cooling system beyond the basic level check. Hoses leading to and from the radiator are traced along their routes, noting how they are secured and how they flex slightly with temperature changes. The radiator itself is observed through the front grille area, where accessible, looking for debris accumulation or bent fins that might affect airflow. The expansion tank cap is examined for integrity, as modern cooling systems rely on maintaining pressure within specific limits. The surrounding area is checked for signs of dried coolant residue, which can appear as pale staining. Electric cooling fans, now common on petrol cars, are also considered part of this system. Their housings and wiring connections are visually inspected, and their operation may be briefly observed during engine warm-up cycles without focusing on performance characteristics. The intake tract beyond the air filter housing is reviewed in a general sense. Modern petrol engines often use plastic ducting and resonators designed to manage airflow and reduce noise. These components are checked for secure fitment and obvious cracking. Sensors located along the intake path, such as mass airflow or pressure sensors, are left undisturbed but noted as part of the overall system layout. Wiring connectors leading to these sensors are observed for proper seating. Ignition components are another area that forms part of routine servicing, even if no direct intervention takes place. Coil packs, spark plug leads, or integrated ignition modules are identified depending on the engine design. The surrounding area is checked for oil ingress or moisture that might affect electrical connections. On engines where spark plugs are accessible without major disassembly, their condition may be inferred from service history rather than direct inspection, as removal is not always necessary at every interval. Attention then moves to ancillary systems that support engine operation. The alternator and its mounting points are observed, noting belt alignment and pulley condition. The air conditioning compressor is similarly reviewed, with attention paid to pipe connections and mounting brackets. These components are part of a complex network of systems that operate continuously when the vehicle is in use, and their general condition contributes to overall reliability. Fuel system components are considered next. In modern petrol vehicles, much of the fuel delivery system is enclosed and managed electronically. Visible fuel lines in the engine bay and underbody are checked for secure routing and protection from heat sources. The fuel filler area is also examined, ensuring that the cap mechanism functions normally and that sealing surfaces appear intact. Evaporative emissions components, such as charcoal canisters and associated hoses, are identified where accessible and checked visually. The service process often includes a more detailed look at braking components than the initial visual check. Where workshop layout permits, wheels may be removed to allow clearer access. Brake discs are examined for surface condition, including the presence of scoring or uneven wear. Brake pads are assessed for remaining material thickness. Caliper bodies and sliders are observed for corrosion or stiffness, and flexible brake hoses are checked again for cracking or swelling. Steering components are also revisited during this phase. Track rod ends, ball joints, and bushings are inspected with the suspension at normal ride height and, where possible, with slight movement applied to observe play. Power steering systems, whether hydraulic or electric, are considered in terms of visible components only, such as fluid reservoirs or motor housings. Any signs of leakage or damage are noted without further intervention. The exhaust system receives additional attention beyond a simple visual pass. Joints between sections are examined for alignment and corrosion. Mounting rubbers are checked to ensure they retain flexibility and support the system correctly. On vehicles equipped with multiple sensors along the exhaust, the wiring and sensor bodies are observed for secure attachment. Heat shielding around these areas is checked again, as it plays a role in protecting surrounding components. Tires and wheels are sometimes rotated as part of a routine service, depending on service schedules. When this occurs, the wheels are moved between positions to promote even wear. Each wheel is refitted carefully, with attention to seating surfaces and fasteners. Once the vehicle is back on the ground, fasteners are tightened to specified values using calibrated tools, ensuring consistent clamping force. With the mechanical aspects largely complete, the service turns toward electronic systems and software-managed features. Diagnostic equipment may be connected to the vehicle's onboard systems to retrieve operational data. This data can include information about engine performance, emissions controls, and system readiness states. The presence or absence of warning indicators is confirmed, and any stored information is reviewed in context. Lighting systems are checked in a systematic way. Exterior lights, including headlights, side lights, brake lights, indicators, and number plate illumination, are observed while activated. Lens condition and alignment are noted. Interior lights and instrument panel illumination are also checked briefly, ensuring consistent operation. These checks are part of maintaining basic compliance rather than fine adjustment. The condition of wiper blades and washers is reviewed again from an operational standpoint. Wiper arms are observed as they move across the windscreen, noting contact consistency and sweep pattern. Washer jets are activated to confirm fluid delivery. Although simple, these systems contribute to visibility and are therefore included in routine assessments. Cabin air filtration, where fitted, is another element of modern servicing. The location of the pollen or cabin filter varies by model, often positioned behind the glove box or beneath a panel. Access panels are opened, and the filter element is removed and examined. Its surface condition reflects the accumulation of dust and airborne particles over time. The housing is checked for debris before the filter is replaced. As the service continues, attention remains on ensuring that all areas previously accessed are returned to their normal configuration. Fasteners are checked for tightness, panels are refitted, and any protective covers are replaced. The engine bay is reviewed as a whole once more, confirming that fluid caps are secure and that no tools or materials remain within the compartment. The engine may be allowed to idle briefly, during which its general behavior is observed without focusing on sound or performance characteristics, as the vehicle settles into a stable operating condition while further routine checks remain underway. As the service continues, attention often shifts towards systems that are less directly associated with engine operation but still form part of the vehicle's routine condition assessment. The drivetrain, where visible, is observed for signs of leakage or abnormal wear. On front-wheel drive petrol cars, drive shafts extending from the transmission to the front wheels are inspected along their length. The rubber gaiters that protect constant velocity joints are checked for splits, hardening, or loss of elasticity, as these components are designed to retain lubricant while excluding dirt and moisture. The transmission casing itself is viewed from underneath, noting its general condition and any traces of fluid around seams or fasteners. While many modern manual and automatic gearboxes are considered sealed units for routine service intervals, their external surfaces can still provide information about long-term condition. Mounting points connecting the transmission to the vehicle structure are also observed, as these contribute to alignment and vibration control. Attention then turns to the suspension geometry and associated components. Control arms, anti-roll bars, and their mounting bushes are examined visually. Rubber and composite bushes are designed to absorb movement and vibration, and their condition is assessed by observing surface cracking, deformation, or separation from their housings. Metal components are checked for corrosion, particularly in areas exposed to road spray and debris. Shock absorbers and struts are observed more closely during this stage. The outer surfaces of dampers are checked for signs of fluid leakage, which may appear as oily residue. Mounting points at the top and bottom of each unit are reviewed for secure attachment. Springs are examined for uniform spacing and surface condition, noting any corrosion or coating loss that might develop over time. The steering rack, where accessible, is another component reviewed as part of routine servicing. Its housing is inspected for signs of fluid leakage in systems that still use hydraulic assistance. In vehicles equipped with electric power steering, the motor housing and wiring connections are observed instead. Protective boots around steering joints are checked in a similar manner to drive shaft gaiters, ensuring they remain intact. The service process often includes a review of underbody protection. Many modern vehicles use plastic or composite panels to shield mechanical components from dirt and water. These panels are inspected for secure attachment, cracks, or missing fasteners. Their presence affects airflow and noise characteristics, so their condition is noted before they are refitted or left in place. Attention may then return briefly to the engine bay for further detailed observation. The throttle body area, where accessible, is identified as part of the air intake system. While cleaning or adjustment is not part of a routine service, its general condition is noted. Electrical connectors in this area are observed for proper seating and the absence of corrosion. Wiring harnesses are traced along their routes to ensure they remain clipped away from moving or hot components. Emissions-related components are considered in a similar observational manner. Modern petrol cars incorporate various sensors and valves to manage exhaust gases and fuel vapors. Components such as exhaust gas recirculation valves or evaporative system solenoids are identified by their position and connections. Hoses leading to and from these components are checked for secure attachment and flexibility. The service process also accounts for the condition of mounting points and brackets throughout the engine bay and underbody. These metal supports hold components in precise positions, absorbing vibration and maintaining alignment. Any signs of cracking, distortion, or corrosion are noted, even if no immediate action is required. Over time, these small details contribute to overall vehicle integrity. Attention then moves to the fuel delivery system from a broader perspective. While injectors and internal components are not accessed, the visible aspects of the system are reviewed. Fuel rails, where visible, are checked for secure mounting. Electrical connectors associated with fuel delivery are observed for proper engagement. The surrounding area is checked for odors or residue that might suggest seepage, even though modern systems are designed to minimize such occurrences. The cooling system is revisited once the engine has been run briefly. Hose connections are observed again, as slight pressure changes can reveal issues not visible when the system is cold. The radiator fan operation may be observed during this period, with attention given to smooth engagement and disengagement. The cooling system cap is rechecked for secure fitment once temperatures stabilize. Attention may also be given to ancillary reservoirs within the engine bay. Brake fluid levels are reviewed again after any movement of the vehicle, ensuring consistency. Clutch fluid, where separate, is also observed. These reservoirs are typically translucent, allowing fluid condition to be assessed visually without opening the system. The vehicle's exterior is then revisited. Door hinges and latches are observed for smooth operation. Bonnet and boot release mechanisms are checked for consistent engagement and release. Rubber seals around doors and openings are inspected for tearing or compression, as they contribute to noise reduction and weather resistance. Wheels are sometimes removed and refitted during servicing, and after this process, wheel alignment is considered in a general sense. While precise alignment measurement is not part of a routine service, obvious misalignment can sometimes be inferred from tire wear patterns. These patterns are observed and compared across tires, noting differences between inner and outer edges. Interior systems receive further attention as the service progresses. Seat belt mechanisms are checked for smooth extension and retraction. Dashboard displays are observed during ignition cycles to confirm that information is presented clearly. Controls for heating, ventilation, and air conditioning are operated across their ranges to ensure consistent response, without evaluating output beyond basic operation. The service also accounts for storage and safety equipment within the vehicle. The presence and condition of items such as warning triangles or tire inflation kits are noted where applicable. Spare wheel compartments are opened, and the condition of stored tools is observed. These elements form part of the vehicle's overall readiness rather than mechanical function. As the process continues, documentation systems are updated incrementally. Digital service records may require confirmation of individual tasks, while paper records are completed in stages. Mileage readings are recorded accurately, and timestamps are noted where required. This administrative aspect runs alongside the physical work, ensuring consistency between recorded and observed conditions. Throughout these stages, the vehicle remains in a controlled workshop environment. Lighting conditions are steady, tools are organized, and movement around the vehicle follows familiar patterns. As further checks continue, attention returns periodically to areas already reviewed, confirming that nothing has changed as a result of earlier actions, and the service proceeds steadily onward without interruption. As servicing continues, attention often shifts toward components associated with vehicle safety and regulatory compliance. The braking system, already reviewed visually, may be considered again from a broader perspective. The condition of brake discs and pads is mentally contextualized against service intervals and expected wear rates. Brake calipers are observed for consistent positioning, and their mounting bolts are checked visually for secure seating. Handbrake mechanisms, whether cable-operated or electronic, are identified and their visible components reviewed without activation beyond normal operation. The vehicle's chassis structure is examined where accessible. Longitudinal members, cross members, and reinforced mounting points are observed for corrosion or impact damage. Modern vehicles often incorporate protective coatings and sealants in these areas, and the integrity of these coatings is noted. Areas around jacking points are reviewed carefully, as they are subject to repeated load during servicing and tire changes. Attention is given to the fuel tank and associated shielding. Although largely enclosed, the tank's visible surfaces and mounting straps are observed for corrosion or deformation. Protective shields designed to deflect road debris are checked for secure attachment. Fuel vapor lines connected to the tank are traced where visible, ensuring they remain properly routed and protected from abrasion. The exhaust system is considered again from the rear of the vehicle. Tailpipe condition is noted, including alignment and external corrosion. Mounting hangers are observed to ensure they retain flexibility, allowing the exhaust to move slightly without contacting other components. The area surrounding the rear silencer is checked for heat-related damage to underbody materials or trim. Suspension components at the rear of the vehicle receive similar attention to those at the front. Springs, dampers, and bushings are examined visually. Rear axle assemblies or independent suspension components are reviewed for symmetry and secure attachment. Where applicable, trailing arms and lateral links are checked for corrosion or distortion. Attention then returns to wheels and tires, with a focus on uniformity. Tire age may be considered by observing manufacturing date codes on the sidewalls. While not part of routine replacement criteria, age provides context for rubber condition. Wheel rims are observed for distortion or corrosion, particularly around bead seats. Valve stems are checked for cracking or looseness. As the service progresses, the vehicle's electrical systems beyond the engine bay are reviewed. Wiring harnesses running along the underbody are observed where accessible, noting their protective coverings and attachment points. Connectors exposed to the elements are checked for proper sealing. These systems support various sensors and actuators essential to modern vehicle operation. Attention is also given to body-mounted sensors and equipment. Parking sensors, cameras, and radar units, where fitted, are observed for secure mounting and cleanliness. Their housings are checked for cracks or damage. Although calibration is not part of routine servicing, the physical condition of these components is noted. The service may include a brief review of the vehicle's interior condition beyond basic controls. Floor mats are removed temporarily to inspect carpet condition and ensure no moisture accumulation is present. Seat mounting points are observed for secure attachment. Interior trim panels are checked for proper fit, particularly those that may have been removed previously for access to cabin filters or wiring. The vehicle's glass surfaces are examined again, focusing on chips or cracks that may have developed since the last inspection. Windscreen condition is particularly relevant due to its role in structural integrity and driver visibility. Window operation is checked across all doors, observing smooth movement and consistent sealing. Door locks and central locking systems are operated to confirm uniform response. Mechanical lock barrels, where present, are observed for smooth operation. Remote locking functions are tested briefly, ensuring communication between key and vehicle systems appears consistent. The bonnet and boot lids are opened and closed again during this phase, allowing hinges and struts to be observed in operation. Gas struts are checked for smooth extension and retention. Mechanical hinges are observed for alignment and lubrication condition. These components contribute to everyday usability and are therefore part of routine observation. Attention then turns to the vehicle's emissions control readiness. While detailed testing is reserved for inspections such as the MOT, service routines often include confirmation that emissions-related warning indicators remain inactive. The exhaust system and associated sensors are considered in this context, ensuring no visible changes have occurred since earlier checks. The service process often involves a short road movement within the workshop area. This may include repositioning the vehicle or moving it between bays. During these movements, basic operational behavior is observed, such as steering response and brake feel, without formal testing. Any unusual resistance or noise is noted for further consideration. Following internal movement, the vehicle is returned to a stationary position for final underbody observations. This allows confirmation that no leaks have developed after earlier fluid changes. The area beneath the engine and transmission is checked again, looking for fresh residue. The oil filter housing and drain plug area are observed closely. Attention may then return to the engine bay for a final sequence of checks. Fluid caps are confirmed secure. Hoses and wiring disturbed earlier are observed again in their settled positions. Engine covers and shrouds are refitted where removed, ensuring alignment with mounting points and fasteners. The battery area is revisited to confirm terminal security following any earlier checks. Battery hold-down brackets are observed to ensure they remain correctly positioned. Surrounding components are checked to confirm no tools or materials remain in the compartment. As servicing continues, administrative records are updated to reflect completed tasks. Digital systems may prompt confirmation of individual inspection points. Paper documentation is filled out methodically, matching observations made throughout the process. This documentation remains aligned with manufacturer service schedules and workshop procedures. The vehicle remains under observation as it sits at rest. The engine may be started briefly again, allowing systems to stabilize. Idle behavior is observed without evaluation. Instrument displays are checked once more to confirm normal status. As the service proceeds further, attention remains evenly distributed across mechanical, electrical, and structural elements, with ongoing checks continuing in a steady, unhurried manner. As the service moves onward, consideration is given to components associated with vehicle stability and ride comfort. Anti-roll bar assemblies, where visible, are observed along their length. The condition of mounting bushes and connecting links is assessed visually, noting whether rubber elements retain their shape and elasticity. These components operate continuously during driving, and their condition contributes to predictable handling characteristics. Attention is also given to wheel bearing areas. While bearings are sealed and not dismantled during routine servicing, their housings and surrounding components are observed for signs of overheating or contamination. The area around the hub assemblies is checked for residue that might indicate lubricant migration, even though such occurrences are uncommon in modern designs. The vehicle's alignment-related components are reviewed again in a general sense. Subframes supporting the engine and suspension are observed for secure attachment to the body structure. Fasteners securing these assemblies are checked visually, noting any signs of movement or corrosion. The integrity of these mounting points plays a role in maintaining consistent geometry over time. Further observation is given to protective coatings applied to underbody components. Many modern vehicles use wax-based or polymer coatings to reduce corrosion. The condition of these coatings is noted, particularly in areas exposed to road spray. Any areas where coatings appear worn or disturbed are identified for record purposes, even if no immediate action is taken. The service process often includes a closer look at the vehicle's cooling airflow path. Plastic ducting and shrouds guiding air toward the radiator and auxiliary coolers are checked for secure fitment. These components help manage engine temperatures under varying operating conditions. Their alignment and attachment points are observed to ensure they remain in place. Attention then returns briefly to the engine bay to observe ancillary fluid reservoirs again. Power steering fluid levels, where applicable, are reviewed once more. Brake fluid reservoirs are observed for clarity, noting the color of the fluid through the translucent housing. The surrounding area is checked to ensure caps and seals remain properly seated. The condition of engine mounts is considered during this phase. Mounts are designed to isolate vibration between the engine and the vehicle structure. Their rubber or hydraulic elements are observed for cracking, collapse, or fluid leakage. Mounting brackets are checked for alignment and secure attachment. The intake and exhaust pathways are revisited from a holistic perspective. From the air intake opening through to the tailpipe exit, the continuity of the system is considered. Each section is observed in relation to adjacent components, ensuring clearances are maintained and that no part of the system appears to contact the body or suspension under static conditions. The service also accounts for components related to vehicle comfort and convenience. Heating and ventilation ducting within the cabin is considered indirectly through airflow behavior. Control panels and switches are operated gently, confirming consistent response. The movement of air through vents is observed without assessing temperature output in detail. Attention is given to the vehicle's seating and restraint systems. Seat adjustment mechanisms are operated through their ranges to ensure smooth movement. Seat rails are observed for secure attachment to the floor. Head restraints are adjusted and returned to their original positions, confirming normal operation. Interior trim panels are reviewed again for alignment. Areas previously accessed during servicing, such as glove box panels or footwell covers, are checked to ensure they are refitted correctly. Fasteners and clips are observed for proper engagement. The general interior environment is left in an orderly condition. The service process may include a brief review of the vehicle's audio and information systems. Displays are observed for clarity and responsiveness. Buttons and rotary controls are operated lightly. The presence of error messages or display irregularities is noted if observed, although no adjustments are made during routine servicing. Exterior trim and body fittings are reviewed once more. Bumpers, wheel arch liners, and undertrays are checked for secure attachment. Fasteners and clips are observed for completeness. These components protect underlying structures and influence airflow and noise characteristics. The condition of exterior seals is reviewed again. Door seals, boot seals, and bonnet seals are observed for uniform contact surfaces. Their flexibility and continuity are noted, as they contribute to weather resistance and cabin isolation. Any visible damage or compression set is recorded. Attention may then turn to the vehicle's fuel economy and emissions-related information systems. Trip computers and efficiency displays are observed for normal operation. Reset functions may be accessed as part of service procedures, depending on vehicle design. These systems provide feedback to the driver but are not adjusted during routine service tasks. The service environment remains controlled and consistent. Tools are returned to storage areas as tasks conclude. Waste materials, such as used filters and fluids, are collected and processed according to workshop procedures. The work area around the vehicle is kept clear to allow unobstructed movement. As the vehicle remains stationary, final visual checks continue across previously reviewed areas. The underside is observed once more for any signs of fluid emergence following earlier refilling and circulation. The engine bay is checked again to confirm stability of all components and the absence of foreign objects. Documentation continues to be updated alongside these observations. Service checklists are completed methodically, reflecting each area reviewed. Any advisory notes are recorded in neutral terms. The service record is brought into alignment with the work performed, ensuring accuracy and consistency as the process moves steadily forward. As the routine service proceeds, attention often returns to the vehicle's operating systems as a whole rather than to individual components. The interaction between mechanical and electronic elements is considered in a general sense, with the emphasis remaining on observation rather than adjustment. Modern petrol cars integrate multiple control units that manage engine operation, emissions, and comfort features, and their physical interfaces are reviewed where accessible. The engine management system sensors and actuators are identified by their locations and wiring connections. While these components are not disconnected or tested individually during routine servicing, their mounting and surrounding condition are observed. Wiring insulation is checked for chafing or heat exposure, particularly where harnesses pass close to metal edges or heat sources. Clips and guides that secure these harnesses are noted for correct positioning. The vehicle's fuel injection system is considered again from a visual standpoint. Fuel rails and injector housings, where visible, are observed for uniform appearance and secure mounting. Electrical connectors associated with these components are checked to ensure they remain fully engaged. The surrounding area is checked for cleanliness, as modern systems are designed to operate without external residue. Attention then moves to the vehicle's transmission controls. Gear selector linkages or electronic selectors are observed for normal movement and alignment. In vehicles with manual transmissions, clutch pedal operation is observed briefly, noting smooth travel and consistent resistance. In automatic vehicles, selector positions are engaged momentarily to confirm normal response without evaluating shift quality. The exhaust after-treatment system is revisited in context. Catalytic converters and associated sensors are considered as part of emissions control. Their external surfaces are observed for signs of overheating or impact damage. Heat shielding around these components is checked again to ensure it remains intact and correctly positioned. The service process often includes a review of the vehicle's cooling airflow management. Engine bay seals and deflectors that guide air through the radiator area are observed. These components help regulate temperature and reduce noise. Their condition and placement are noted as part of the overall system. Attention is given to the vehicle's underbonnet sound insulation. Insulating panels and pads are observed for secure attachment and uniform coverage. These materials contribute to noise reduction and thermal management. Any sagging or displacement is noted. The service also accounts for the condition of fasteners and fixings throughout the vehicle. Bolts, clips, and screws that secure panels, covers, and components are observed for completeness. Missing or mismatched fasteners are noted, as they can affect component stability over time. Attention may then turn to the vehicle's lighting systems from a physical standpoint. Headlamp housings are observed for condensation or damage. Mounting points are checked for secure attachment. Wiring connectors at the rear of lamp assemblies are observed where accessible. The vehicle's braking hydraulics are considered again after earlier inspections. Master cylinder areas and brake fluid lines in the engine bay are observed for signs of seepage. The brake fluid reservoir cap is checked for proper seating. The surrounding area is checked for cleanliness. Interior electrical systems are reviewed again during this phase. Fuse boxes, often located in the engine bay or cabin, are identified. Fuse covers are opened and closed to ensure secure fitment. The presence of correct fuse types and ratings is noted without removal or testing. Attention is also given to the vehicle's steering column and associated components. The column housing is observed within the cabin for secure attachment. Adjustment mechanisms are operated briefly to confirm smooth movement. Electrical connections related to steering wheel controls are considered in terms of their routing and protection. The service process includes further observation of body drainage paths. Water drainage channels around the windscreen scuttle and door apertures are observed for blockage or debris accumulation. These channels help manage rainwater and reduce the risk of water ingress into the cabin or engine bay. The condition of exterior mirrors is reviewed again. Mirror housings are observed for secure attachment. Adjustment mechanisms are operated to confirm normal response. Integrated indicators or heating elements are considered as part of the overall assembly. The vehicle's wheels are revisited to confirm correct seating after any earlier removal. The contact between wheel and hub surfaces is considered in a general sense. Valve caps are checked for presence, as they contribute to valve protection. Attention is given to the vehicle's tire pressure monitoring systems, where fitted. Sensor locations are considered indirectly through wheel and valve configuration. Warning indicators are observed during ignition cycles to confirm normal status. The service environment remains unchanged, with the vehicle positioned securely and lighting consistent. Movement around the vehicle continues in an orderly manner. Tools used earlier are accounted for and returned to storage. As the service advances, further checks continue across previously reviewed systems. The vehicle remains under observation, with no emphasis on performance or outcome. The process proceeds steadily, maintaining focus on consistent inspection and documentation while additional routine observations continue without interruption. As the service continues toward its later stages, attention remains on ensuring consistency across systems already reviewed, rather than introducing new interventions. The vehicle's overall condition is reassessed by revisiting key areas with fresh perspective, confirming that earlier observations remain unchanged after subsequent movement and operation. The engine bay is observed again with the engine in a settled state. Components that may have shifted slightly during earlier checks are reviewed in their resting positions. Hoses and wiring are observed to ensure they lie naturally along their intended routes, without tension or interference. Any components that rely on clips or guides are checked for continued alignment. The condition of ancillary belts is reviewed once more after brief engine operation. Belt surfaces are observed for consistent tracking along pulleys. The alignment of pulleys is considered visually, noting whether belts appear centered and stable. Tensioners, whether automatic or fixed, are observed for normal positioning. The vehicle's fluid systems are revisited as a group. Engine oil level is confirmed again after circulation. Coolant level is observed in the expansion tank, noting stability relative to earlier checks. Brake fluid and clutch fluid reservoirs are observed for unchanged levels and clarity. Washer fluid is checked for sufficient volume. Attention returns to the underside of the vehicle, either visually from ground level or with the vehicle raised slightly if required. The area beneath the engine and transmission is observed again for any fresh signs of fluid emergence. Surfaces around drain points and filter housings are checked for dryness. The exhaust system is considered again in its entirety, from front to rear. Mounting points are observed under static conditions, noting whether the system rests evenly without visible strain. Clearance between exhaust components and surrounding structures is considered, particularly near suspension elements and heat-sensitive materials. Suspension components are reviewed again from a settled position. Springs and dampers are observed under the vehicle's own weight, noting uniformity of ride height from side to side. Bushings are observed for consistent compression. No adjustments are made, the focus remains observational. Steering components are also reconsidered briefly. The steering wheel is turned slightly from side to side while stationary, observing the response of linkages and joints where visible. Movement is smooth and limited, with no emphasis placed on resistance or feedback. Attention then returns to the vehicle's braking system. Brake pedal travel is observed briefly while stationary. The pedal is depressed and released without emphasis, confirming normal movement. Brake warning indicators are observed during ignition cycles, confirming expected behavior. The vehicle's wheels and tires are reviewed once more. Tire pressures are rechecked if earlier adjustments were made. Valve stems and caps are observed for secure seating. Wheel fasteners are visually confirmed to be fully seated. Exterior lighting is reviewed again in a final pass. Headlamps, indicators, and brake lights are observed for illumination consistency. Lens surfaces are checked for cleanliness. No alignment changes are made. Interior systems are revisited with similar restraint. Instrument displays are observed during engine start and shutdown. Warning indicators illuminate and extinguish as expected. Audio and information displays are observed for stable operation without interaction beyond basic checks. The cabin environment is returned to its original state. Seats, mirrors, and controls adjusted during servicing are reset. Floor mats are replaced. Any panels or covers removed earlier are checked once more for secure fitment. The service documentation process continues alongside these observations. Checklist items are reviewed for completeness. Digital entries are confirmed and saved. Any advisory notes are recorded in neutral terms, reflecting observed conditions rather than recommendations. The vehicle remains positioned within the service bay as these final checks continue. The surrounding area is cleared of tools and materials. Waste containers are sealed and removed from the immediate workspace. As the service moves closer to completion, the vehicle is observed during a final period of stationary operation. The engine may idle briefly, allowing systems to stabilize. No new observations are introduced at this stage. Attention remains on confirming that previously reviewed systems continue to present consistently under settled conditions, while the process proceeds calmly toward its remaining routine stages. As the routine service proceeds into its final phase, the emphasis remains on maintaining consistency and confirming that earlier observations still hold true after all routine activity has taken place. The vehicle is treated as a complete system, with no single area receiving priority over another. Instead, attention moves evenly across mechanical, electrical, and structural elements that contribute to normal operation. The engine bay is observed once again, this time with all covers and shrouds refitted. The alignment of these panels is checked visually, noting that they sit flush with surrounding components. Fasteners securing these covers are observed for proper engagement. The general arrangement of the engine compartment is reviewed as a whole, confirming that hoses, wiring, and fluid reservoirs appear undisturbed. Engine idle behavior may be observed during this period without assessment or judgment. The engine is allowed to run briefly while stationary, providing an opportunity to observe system stability. Cooling fans may operate depending on temperature conditions, and their engagement is noted without emphasis. No adjustments are made during this observation. The area beneath the vehicle is considered again after the engine has been run. The ground surface beneath the engine and transmission is observed for any new markings. The underside of the engine bay is checked for dryness around previously accessed points. This observation is brief and routine. Attention returns to the vehicle's wheels and tires for a final visual review. Tire sidewalls are observed for unchanged condition. The relationship between tire and wheel arch is considered to confirm consistent ride height. Wheel alignment is not adjusted, but obvious deviations would be noted if present. Exterior body panels are reviewed in passing as part of the overall inspection. Panel gaps are observed for uniformity. Doors, bonnet, and boot are opened and closed once more, allowing hinges and latching mechanisms to be observed during operation. Gas struts are noted for smooth extension and retention. Lighting systems are observed again with the vehicle stationary. Indicator operation is confirmed briefly. Brake lights are observed during pedal application. No adjustments are made to lamp position or brightness. Inside the cabin, controls and displays are returned to their standard positions. Any temporary adjustments made during servicing are reversed. The steering wheel and seats are returned to neutral positions. Climate control settings are returned to default states. The vehicle's onboard systems are observed one final time during ignition cycles. Instrument displays illuminate and extinguish in their expected sequence. No new indicators are introduced. Audible alerts, where present, follow their usual pattern. Service documentation continues to be finalized alongside these observations. Mileage and date entries are confirmed. Electronic service records are synchronized where applicable. Physical documentation is completed with consistent handwriting and terminology. The service bay environment remains orderly. Tools have been returned to storage. Equipment used during earlier stages is no longer present around the vehicle. The floor area surrounding the car is clear. As the vehicle remains stationary, attention rests briefly on its overall condition in the service bay. The engine compartment, underbody, wheels, and interior have all been reviewed multiple times under stable conditions. No new areas are introduced for inspection at this stage, and the service continues through its remaining routine steps, maintaining the same measured pace and observational focus as before, with no distinct endpoint marked within the process.